Okay, let's now implement the withdraw function for the depositors. But first, quickly, what we actually haven't done yet is we said in a case when the contract is currently in a deficit, we prevent burning the stablecoins to kind of prevent a bank run on the system. So in the burn function here, the first thing we'll actually have to do is check the current deficit or surplus with the function here that we implemented, the get deficit or surplus, and then require that this is in fact not negative. And otherwise cannot burn while in deficit. Okay, so now let's go ahead and implement the withdraw function for depositors. Okay, so let's just add it right after the deposit function here. And let's add a function withdraw collateral buffer. And you pass in the amount of depositor coins that you want to burn. So uint 256 burn depositor coin amount. And of course, it's an external function that is in this case not payable because you're not actually sending any ETH along with it. Quite the opposite, right? You're actually getting ETH in return now for burning this depositor coin. So we can actually just call depositor coin .burn msg.sender and the burn depositor coin amount. And I mean, the burn function we implemented already has this automatic check to underflow if the sender wouldn't have enough tokens. But let's just give it a nice revert message quickly by just checking that depositor coin balance of msg.sender is in fact bigger or greater or equal to the amount that was passed. So this is a bit more meaningful error message then. And we can say sender has insufficient DPC funds. Okay, so now we actually have to figure out how much ETH to send him for his burn transaction here. And remember, we have this function to calculate the price. And of course, depositor coins here are only worth something if the contract is not in a deficit. So we know how to check for a deficit or surplus by now. We've done it a few times. So that's just using this function that we have and deficit or surplus in USD and using this function here, get deficit or surplus. And then if it's in fact a deficit, so we require that it is positive, because if it's negative, we revert with a message no funds to withdraw. So now we know, okay, there is a surplus in this case. So let's convert it again, surplus in USD. And yeah, we can just convert it directly because we know it's now a positive number. And then let's get the price of the depositor coin. We also have done this before, so that's just using the function again here, get DPC and USD price, and we pass in the surplus in USD. And then the amount that we're refunding him in USD is just the burn depositor coin amount divided by this price in USD. And then we just convert it again quickly in ETH. And that's just this refunding amount in USD divided by the Oracle price. And then we can actually send it back to him. And we've done that before a few times now. So that's just msg.sender.call with the value of refunding ETH. And no data. And we'll check that it was actually successful by checking that the Boolean success is true. Otherwise, withdraw, refund, transaction failed. And I won't break it too little. And this is now the withdraw function for the depositors. And this is actually almost all of the contract that we've implemented now. There's one little thing missing that I don't want to say quite yet, but otherwise the main functionality is actually done, and this is a working stablecoin.